So if you have gotten through the first 23 videos, you have gotten through the first year geometry course. This is where the book changes. These questions are from book 2. If you want to push yourself further and continue with transformation geometry, you'll see that there's not much of a step up between first year and what's actually required for the junior cert. Now this is just a little bit of revision. Can you remember an object that has two axes of symmetry, a rectangle? Go back and look at axes of symmetry. If you don't know the answer to these, 3 will be an equilateral triangle. You're asked to draw them here, but I'm just going to put them down. And 4 will be a square. 5 will be a pentagon. 6 will be a hexagon, and so on. So in question 2, you're asked to, in each part A to E, show all the axes of symmetry. So there's a rectangle here, so we have 2, 1, 2. This we will consider to be a scalene triangle, as there's no information given, so we'll say 0 here. The star would have a few. If we come down this way, we'd be able to divide the star in half, vertex to vertex. There's another one. There's another one. 3 going that way. In this guy, could be 1. There could be 1 here. This does look like it's split in half, but it could be a little bit deceptive, but that does look like an axis of symmetry. In this guy here, we could divide it down like this. I don't think there's any others. And in question 3, in each question below, 3 images labeled A, B, and C are the images of the object under a transformation. So we have our object, so what's happening to it? The transformation could be a translation, an axial symmetry, or a central symmetry. For each image, state which transformation has been used. So you can see here, P going to the first image here is a translation. It could also be a full rotation, but in this case, we're going to call this one a translation. For B, back to front upside down, a central symmetry. So this one here, central symmetry, we'll call CS. We'll call this one T for translation. And P, well, this is through the axes and out the other side, so this looks like axial symmetry, which we will call S or AS. For object B, so it's back to front and upside down here in A, central symmetry, back to front upside down, just back to front. So there's axial symmetry here, has to be axial symmetry. And this one here has to be a translation. It's in the same direction. Object A, hard to tell with the leaf here. The obvious one is a translation for B, and central symmetry for C. So this has to be axial symmetry for A. Nice easy questions. And in question 4, 3 images labeled A, B, and C. The image of the object under a transformation. So we have a translation, and again axial symmetry and central symmetry, but in this case they've thrown in a rotation. For each image, state which transformation is used, and in the case of a rotation, so one of them must be a rotation, state the angle and direction. 4A looks like it could be a rotation, but if you imagine the boot rotating that way, it'll be, when it gets to this point, the boot will be here, but in the case the boot's not here. So that was my first thought. Oh, it looks like a rotation, but if you imagine the object sitting on top of A, everything is being mapped down this way. So it's axial symmetry for the first one here. Axial symmetry through the x-axis, possibly. For B, we're looking at, well, it's the same direction, translation, that jumps out, that's really obvious. And for C, well, is C the rotation that we were talking about? C is the rotation that we were talking about. This is a rotation of 180 degrees, this one here. Or we could also call that a positive 180 degree rotation. It could be negative too, because we'll end up in the same position. Is any of these flags the same? Any of them? A looks like a translation, does it? Very hard to tell. A is a translation. B looks like it's been mapped through the axes. It has. B is axial symmetry. And is it back to front upside down? It is for C. So that could be central symmetry, or it could be a rotation around the origin, but we'll call this one central symmetry. But these two things are the same.